Good morning. Is there massive traffic today? Is that what's going on? I'm glad you're all here. We're missing some essential people. Yeah, we're missing like 6, 7 people. I'm gonna wait just a few minutes. Oh, I like that sweatshirt. Again, if you have your test corrections, go ahead and leave them on the desk. See, that's why I come to class late, out of breath. Right? I appreciate that. Good morning. All right. Okay, I think we're pretty much filled in. Good morning again. Morning. If I don't have your test corrections, just make sure to leave them on my desk at some point. James, do them after you get your test back. Yeah. Let's see. We have a test coming up, don't we? Pretty soon. I think we're like approaching the end of the chapter again. Let's see what we're looking at. Did I put it on this? Tuesday, October 17th. Oh, before that, we have a quiz. Oh, we got a lot of time though. We have a test coming up, but it's not coming up anytime soon. Okay. I don't have your quizzes graded yet. I'll have them by next time. I apologize for the delay. Next time. We have Friday. We have something to look forward to. That should be a fun one. Let's do this. But today is 1.4. Yeah, so 1.5, so day 6. Brandon, can you do me a favor and close that door, please? I feel so anticlimactic introducing this in Algebra 2. I feel like most people know what an imaginary number is. Would you just check with the neighbor and see if they actually know what an imaginary number is? Okay, so we know that imaginary number is what? The square root of -1. Does it sound familiar? It comes from the fact that mathematicians are not happy when you get something that you can't solve, something like this, like quote unquote can't solve. So x² + 1 = 0. So we go through the algebra. There should be a solution. So we've come up with a solution, and it is in the imaginary realm. And early part of imaginary numbers, there was no application for them. But there is now, they found applications, I believe, in fluid mechanics, oddly enough, or something like that, some sort of differential equation kind of business. But really, it's just to make the solution sets complete. So, of course, when we take the square root of an unknown, don't forget that there are 2 answers. That's why the answer here is plus or minus square root of -1. And by definition, square root of -1 is I. Normally you see it italicized. I put a little curly thing on the bottom. Not to be confused with the J that goes the other way and it's longer, so be careful. So whatever you want to do, just make sure that you know what you're dealing with. This is actually called the imaginary unit, because when you have something like x squared plus 4 equals 0, you get x squared equals -4. X equals plus or minus 2i. Anytime you're taking the square root of a negative number, it's going to be an imaginary number. So there are an infinite number of imaginary numbers, but only one imaginary unit, the square root of -1. Cool. Now your knowledge of numbers is complete. That's the last number you're ever going to really talk about in any sort of high school math class, and probably any math class at all, as far as I know. Let's play with it a little bit. We know that I equals I. What property is that called? Identity property of equality. You're not going to be tested or quizzed on that. I couldn't care less if you remember that. But I squared. Would you please think about what that equals and discuss with your partner? What does that equal? So I squared. I want to hear from someone. I want to hear directly from this amazing young student. Ryan, do you have any idea? Do we agree with Ryan? -1 is correct. Thank you. Which kind of strange that when you square something, it results in a negative number, but we're in an imaginary number realm. Things are a little bit different here. I cubed. Take a moment to discuss that one and I to the 4th. We want to simplify these, if possible. I cubed. Is anyone able to simplify this one? Give it a shot. You can't simplify it satisfyingly, I'll tell you that much. But you can simplify it a little bit. I cubed by that, and I'm going to do a little bit of work up here. I cubed is equal to I squared times I, isn't it? So do you see how that simplifies? -1 times I, which is negative I. Like we wouldn't say -1x, we say -x. So yeah, this is, although you're right, -1 times I, we say just -I. You smell pirates joke coming? No? I don't know. I to the 4th. Or think about it. Right, discussion. So what is it? What is it? 1, are we good with that? And if you want to do a little bit of work, I to the 4th is I squared times I squared. -1 times -1, I think, is 1. Let's keep going. I to the 5th power. We could do this all day. We're not going to. We could though. I to the 5th. How does that simplify? And I to the 6th. Okay, I really want you to work on both of these. I to the 5th and I to the 6th. So, anyone get it? I to the fifth would be rewritten as I. Why I? Baron for 300. -1. So you did this. You did I squared times I cubed. Is that right? Or I to the fourth times I, either way. So the first way would be -1 times, we already said that I cubed is negative I, is that right? Which gives us I, or I to the fourth times I equals I. Do we agree that either way you do it, it's going to be equal to I? Okay. Did you get I to the sixth already? You show me your answer. Yeah, negative numbers remember downwards. -1. So I to the seventh, do you know what that's going to be equal to? Did you work through that, or there's no need to work through it? You found what we're dealing with here. We're dealing with a pattern of 4, right? So in fact, I'm going to put these up here. I to the fifth equals I, and I to the sixth equals negative I. Do you know, does anyone know how to display I in American Sign Language? Oh, nice. Oh, 2 partners. No, this is I. So this is I. Negative I would be, that's not official American Sign Language. Do you know J? Once you know that, yeah, scoop it, J. Okay, just as a small tangent. So now I hope you see why I said that I is equal to I, just so we can continue this pattern. Of course, this would be equal to negative I. I to the eighth is equal to 1. I to the ninth is equal to I, et cetera, et cetera. So you're going to see questions like this. What is I to the 27th? I want you to discuss with your neighbor. What is I to the 27th power? Okay, show me what your answer is, please. I'm seeing a lot of this. Down, down, down. Nice. Negative I. Who'd like to explain how we know? Yes, Jane.
I multiplied 6 times 4, and then I had like 3 more, and I got the one.
And why did you do 6 times 4 instead of like 9 times 3 or?
Because 6 is 24, so 6 is like the factorial, I guess. And with a 4, I 12.
Nice. Are we good with that? There are a lot of ways to break this down, but I really like what you did here. I really like that you kind of highlighted that 4. I think that makes a lot of sense to think about how you did. So we have that this is equal to either fourth kind of, I think this is kind of what you were thinking, isn't it? And that left you with I cubed. So this, of course, is equal to 1, and this is equal to negative. Did anyone think about it in a similar fashion? Because honestly, you could do things like this, and students always like, they want to find other ways to do things, which is great. But do you see how this kind of leads to more problems? Because I cubed is negative I, and then you have to figure out negative I to the 9th power. So I recommend finding the 4 in it, and then the 3 could just come from finding a remainder. Does that make sense? The 3 is that remainder of division. And once you have that I cubed, you probably have to know I cubed. Welcome. Hello. One last thing. Square root of -4. We know that that would be. Are we good with that being 2i times square root of -9? Is this equal to the square root of 36? No. If we deal with imaginary numbers, then the rule of radicals does not hold any longer. We can't just multiply these numbers together. We have to recognize that there is an imaginary number here. So this is 2i, this is 3i. 2i times 3i is 6i squared, which is equal to -6, isn't it? We just established that I squared is equal to -1. So that says 6 times -1. So the 6 is there, but we need that negative. Everyone feeling good? Any questions? Do you kind of like it? This I business? I'm seeing some mixed reviews. Okay, you can't win 100% all the time. It's okay. I hope you don't hate it.
What would have to be like to make it like I squared plus 5i.
What are you talking about?
On the 2i and 3i. So why don't you make it one? Like why don't you have to distribute on it?
Multiplication, distribution only happens over addition and subtraction. Like if, and we're going to be doing that today, but if you have something like 5 times x plus 3, that's when you distribute. With imaginaries or not. Complex numbers. Complex, it's not complex in that it's complicated. It's that there are different parts. Like an apartment complex isn't like, oh my gosh, it's so complicated here. It means there's a lot of parts going on. So complex number, by definition. Have you heard of complex numbers? Let me welcome you to the world of complex numbers. Complex numbers, by definition, is a number in the form of a plus bi. A is called the real part. And bi is called the imaginary part. Imagine that. For example, 2 plus 3i is called an imaginary number. It's a single number. We can't graph it on a number line because there's an imaginary portion, but it is a single number with 2 parts. We can't combine them because they aren't like terms. One's real, one's imaginary, but it is together a single number. -4 plus I. That's an imaginary number. 6. Is that an imaginary number? I'm sorry, is that a complex number?
No.
It's a complex number because it is 6 plus 0i. So every number you've ever dealt with is a complex number. It just has been missing the imaginary part. Like it's been a little bit empty. It's missing half of the things. That's okay though. So -2i, is that a complex number? It is a complex number with only an imaginary part, but it still is a complex number. It's 0 minus 2i. These are all complex numbers here. So operations with complex numbers. Well, just like all numbers, you could add them together, subtract, multiply, and divide. If we have 4 plus 3i plus 5 minus 6i. You see how you would add these? It's not surprising or difficult. You just combine like terms. It's 9 minus 3i. If we have something like 2 plus 7i times 3 plus 4i. I said, yeah, times 3 plus 4i. Can you do this operation? Can you multiply these two together? I think you can. I'll give you just a moment to finish that. gonna call on someone to help me out here, so make sure you're checking on your neighbor. Once you're done, or if you're done. Did you get it? You get something? Yeah. Okay. The universe has smiled upon Dylan. Can you help us out, Dylan? And just step by step, what'd you do? Okay. Does she speak the truth? Okay. Oh, 20, 21. Thank you. I wrote too quickly. Continue. Okay. 29 minus 22. Nice. Are we good with that? Very nicely done. Now, if you're multiplying and or doing any operations with complex numbers, I want you to make sure that your result is a complex number, which means we're going to take that answer and I'm gonna flip it. I want the A plus BI. Always. In other words, this is going to be negative 22 plus 29.5. So they're both correct, but I'm looking for form. It's just like grammar, not the stuff. Any questions? Maybe your question is, can we have a few to practice? In which case the answer is yes. Here you go. Your dream has come true. Isn't that funny? How many of these are there? There's I of them. They skipped H. I wonder if that was on purpose. I'll be calling on 8 people. Universe will be calling on 8 people. No matter where you are, just quickly check in, make sure your answers are matching your neighbors. gonna give you an H here. Okay. Any time to discuss? Check in. Each. Okay. I just like the answer, please. Sasha, what is A? Thank you. And if anything is wrong, and I'm not saying this is wrong, by the way, but if anything's wrong, save it for the end. We'll get to it. Nia, B. 6 plus 7, I you said? Thank you. Chloe? Plus 5? 5I, okay. Thank you. Lily? Oh. Oh, plus I see. I see. Okay, A plus I. Thank you. I'm sorry. -10 plus 7I. Thank you. Sophia? Plus Emma? Ava? James? For you do I, please? That's awesome. Okay, so you do H, please? 11 plus 60. Did anyone want to change their answer? Okay, are we good with all these? Well, I think they're all correct. Yeah, Nia? What's that? So should be put 100 plus 12 out there. What I would be looking for. Would I take off for something like that? Yes, I would take off 1 point. So if it's a 10-point problem, I take off a point. If it's a 2-point problem, I take off a point. If it's a 1-point problem, I take off a point for having it in that reverse order. So please be careful. Thank you. Okay. So you may have a question. Mr. Lieberman, we've added, we subtracted, we multiplied, but aren't there more operations like division? Well, yes, let's do some. Shall we? Excited? Are we dividing a complex number by a complex number? We are. That is division. I'm gonna give you a moment to discuss with your neighbor. How would you do this? Okay. I'd like to explain. What do we do? Any clue? I heard the key word, yeah. Man, I think it came from you. Oh, okay. Nice. Yeah, nice. Yeah, so yeah, conjugates. You know that A plus B times A minus B is equal to A squared minus B squared. So that's just conjugates, but complex conjugates, A plus BI times A minus BI. When you multiply those out, you get A squared minus BI squared, don't you? You see what happens from there? How does that simplify? It becomes A squared. You see it? Plus B squared. Or you start with two imaginary complex numbers, and then the imaginary part just goes because they're both squared and there's no middle term. So we are going to be using that. We're going to be multiplying top and bottom by 4 minus I. I'll give you a moment to do that. When we're done, I will be calling on someone to tell us what they got. I think I'm calling everybody. I just have to call me so far. Just A. Ready? You ready? For A? Ready or not? I'll give you 10 seconds. Okay, Ivy, can you help us out? A, please. Minus what? We got squared. B plus 12I over 17, you said? Do we agree? Any questions about this? Perfect. There's just one little problem. You're dividing a complex number by a complex number. I want the results to be a complex number. Right now, it's in the form of a complex number divided by a complex number, isn't it?
Complex number divided by a complex number with only a real part, but so. It's presented as a division problem. So how do we get out of it?
Quite simply. Yeah. What's it? What do you mean flip?
Like when 12I plus.
Well, we want A plus BI for sure. We want the real part first. Although that would be true, it's not what I'm looking for. There's a phrase I used to call pulling a Moses. Have I discussed that before? Pulling a Moses. No, Moses. I don't. This is referencing the Bible, literary sense. So we know that A over B plus C over B is equal to A plus C over B. But if we start with A plus C over B, does it make sense that we could rewrite that as A over B plus C over B? Pulling a Moses, right? We take that fraction and just say, oh, we can rewrite this as 3 over 17 plus 12i. Well, I'm gonna actually write 12/17 I. Though if you want to keep the I in the numerator, you may. But purely complex numbers, here's our A plus. Question. Okay, no problem. There you go. Well, when I say no problem, here's 3 problems. Now we find 3 people. What do you know? Want to check with the neighbor? That's great. If you just give me your final answer, that's what I'm looking for. So Brandon, what did you get for B? 1/10, you said? Plus 7i over 10? Like that? Okay, and you could put the I on top if you like. For C. Mia. I'm sorry, negative. Okay. Over 29. Okay. You all like to play it safe. Like the I on top. I'm gonna bring it down just a little bit. I'm gonna do that. Who's next? Baron. You haven't had a chance to talk today. Any questions? Excellent. Yeah, perfect. Just make sure that if you're using this I on the side method, it's not dropping to the bottom. I'd be careful of something like this. That's the only danger with not putting it on top. You put it down here. There's a chance I'll mark you off, especially if it kind of goes under it somehow. Like your pressing bar is a little bit like carelessly long if you're not thinking about it. So please be mindful when you're doing these complex numbers to put that I in on the side or on top, never down below. Okay, I'm gonna give you 3 minutes until 46 to zone out. Principal square root of a number, I think we've already discussed this. It's not plus or minus 9i, it's just 9i. Although every number has 2 square roots, this is talking about the positive square root or positive 9i. So B, technically, and you're breaking up that 75 into 25 and 5, aren't you? With the I. So 5i root 3, something like that. But since it's an imaginary number, although you may write it like this, and I'm not going to take off any points, some may argue that this is more appropriate. Right, the coefficient with the letter in the end. But just be careful if you're going to do it like this, because if I see this, then it's suddenly wrong, even though I know your intentions. Just please be careful. So just mindfulness all the way. I'll let you finish C and D. We can finish it together. It's no pressure. It's an upward grade. Brandon, see what you get.
Four I root five.
Or I read 5. Are we good with that? Cool. I'm gonna write it like this. I'm a purist. I'm not gonna force that on you. But you get extra credit if you do that. Just kidding. When I talk about extra credit, I'm talking about extra credit right here. There's never extra credit in the grade book. Priscilla, did you get D? And then what happened? Oh, do you agree that it's 59?
Yeah.
Okay. And then you had a hard time breaking down to 59, huh? Well, I think 59 is a prime number, isn't it?
Yeah.
Which means the only thing we could take out of that radical is I. Yeah, so it becomes root 59 I. Or if you're chicken, I mean, if you're playing safe, I root 59. So you're right there. My suggestion is to be comfortable with these. I'm just because there's no negative. Exactly. If there's any negative in a radical, it's true. That'd be fully simplified. 18 becomes what? 3 root 2i. Negative 8 becomes 2 root 2i. When you subtract these, you get root 2i. Let's finish. 5 more. 15 seconds. Okay, so if you're not done, we'll finish it together. Baron, can you tell us what we got for B?
Oh yeah, 7 I.
Like this? Are we good with that? I need some help with C. I was hoping Ava could help me. Can you talk me through that one, please? Okay.
I just know that when it's so that I.
Six minus two. Why don't you think that's right? First step seems okay. Second step. I guess the question is it +5?
Hey, so this is +5. Well, root -5 times -5 is -5.
We have to keep those negatives in there. All right, that is the tricky part, which changes things, doesn't it?
Yeah.
So. -4. Any questions? I do want you to bypass this. Does that make sense? I want you to bypass that. Instead, I want you to use, and I know we're kind of in unfamiliar territory, so it's more comfortable to do that. I really want you to focus on A plus B quantity squared. It works for both real and imaginary numbers. So we know that's going to be A squared plus 2 plus B squared. Let's make sure we're okay with doing it this way. This would be -1 squared is 1 plus 2 times -1 times square root of -5 plus B squared. When we square that, we are left with a -5. I'm crashing that -4 times. Nothing wrong with this, but I eventually want to let that go. And moving on. Emma, can you help me with D, please? I'm sorry, please start again. You said 2? Is that what you're starting with? Okay. Oh, times -2. Excuse me. Times -2. Okay. Where did this first 2 come from? That 2? And 2 squared is like 4. Okay. Are we good? Okay. So I hate those kind of errors. Keep on going. When I say I hate it, I hate when I do those kind of errors. And I'm passionate for you on it. Do you have any like terms here? 1. Let's fix up this mess. Square root of -3. Become. Are we good with that? We're not ahead now. It's very nice and done. I'll write it like this. You get it. What is 2 times -2? Nice and done. Ivy, you're up. Day 25. All over 15. Okay. This good. One more. Ryan, I saved this for you. A radical of 3. Oh, then that's it. And you didn't talk about I in it. I is definitely outside radical. For those of you doing that, out of radical. If you want, you could make your radicals kind of like that, a little tail on it to signify the end, just to make sure. Are these all good? Comfortable with this? You're enjoying the complex and imaginary numbers. One last thing, which we've already done, since we already did 8 to 27, just 8 to 43. Go ahead and do these 4 problems, please. Okay, I'm gonna call on everybody, show me the answer for A. What's this, is this true? How do we know it's, is this one? Alright. You said I to the 40 times I cube, and you're doing multiples. But because I do anything that's a multiple of 4 is just gonna be 1. It simplifies very quickly. B, show me what you got. Make ones all around. How do we know it's -1? Parent for 500. Really comes down to the remainder when you divide them. See, show what you got. Once again, show me what you got. Answers. James, could you help us out here? Yeah, so I got I. You good with that? They will do this a different way with that, sure. And T. Got it. One time goes one. Is a multiple of 4. Multiple 4 will just be that. I think we have a bonus one. You thought it was over, didn't you? Nope. Surprise! There's an E for extra. E to the -7th. Oh, what? What? He went to negative exponents. Discuss. Have a question or do you have? So what you got? What you got? What of everything? I'm going to think to you. It should be just a single answer. It's like an answer. I don't want one over something. I want an answer. I don't want a problem. I want an answer. What is it? Anyone want to take a stab at it? Well, it seems like what you did is 1 over I to the 7th. Are we good with that? Then we of course know that I to the 7th is negative I. 1 over the negative I. Have you seen a problem like this? Running by a complex number? That, which is rational. Multiply top to bottom by. I multiply by the complex. I think either way would work. Begins with I over negative I squared, negative I squared.
So probably
Did it follow the pattern?
following the opposite pattern of the negative numbers.
I think it's the same pattern. What I would do something like this. When I say the word I, does it stick out in your mind like, oh, I? Okay. Becomes what inside. Consider it. Great job today, folks. Who imagined this would be so amazing? Alright. Have a good day, everyone. I'll see you Wednesday. Stop.